Welcome to my channel. I'm Zhang Xu. Let's look at the problem 66 at chapter 7. This chapter talks about work and energy. And now there is a box, and we see what happens. You can see the mass of the box is given, and we know the initial velocity is 0 because it starts from rest. And then there is a force acting on it. This force is horizontal, right? The magnitude is 225 Newton. So then this box moves to the right. And at the D1, the first displacement, there only the force F pull act on this box on horizontal. Then there is a friction act on this box. This friction comes from the coefficient of friction 0.2. It tells you. So because you know the coefficient of friction, so you must consider the friction force. The friction force is the coefficient times the normal force. In this case, the normal force is just equal to gravity. Do you agree? Yes. So then we find the friction. Friction pointing backward. And there's still the force pull act on this box to the right. And then this box moves another displacement, d2. And then finally it reaches this position. Ask you what is the velocity at there, v2. See, this problem is a very typical work energy principle problem. You can see you know the mass and you know the initial velocity. You want to know the final velocity. It looks like we can find the initial kinetic energy, and we can find the final kinetic energy. And we know the change of the kinetic energy equals the net work act on this object. Agree? So now can we find the net work act on this box? Sure. Because we can see at part 1, we know the force and we know D1. So very easily we can find the work done. This one is F pull times D1. And then you can see at the part 2, the work act on the box come from the force F pull times D2, right? And also this is pointing to the same direction. So the cosine 0 is 1, so F pull times D2. And same thing we look at there, another work we need to consider comes from friction. So you can see the friction force act on this object, and then these two friction force and the displacement at the opposite direction. So this is cosine 180 degree becomes -1. Therefore, we can find the net work act on this object is the pull force times D1, D2, agree, times D1 plus D2. This is the work done by the pull force. This is a pull force, right? The force times the distance. And also the friction comes from the mu k mg, and then the distance it covered d2, and these two are the opposite direction, -1 there. So the net work is this one. Now we consider the work energy principle. Final kinetic energy minus initial kinetic energy equals net work. And then V1 equals 0, so we input then V1 0 there, and the input net work there. We can solve this equation, find the V2. Then you can input all the numbers inside, get the final answer as 13 meters per second. Thank you.